Hello, DC-CAS Strategies. Welcome to day number 5. I'm Mr. Ken.
And I'm Mr. Athman.
And today we're going into the big house. We're going into Mr. Smith's room. He teaches calculus. And in order to know calculus, you gotta know algebra.
That's what we're going to do today. Let's see if he's home. I see him coming. We're on the 4th floor, calculus room. Here we go.
Hey, Mr. Smith.
Hey, Mr. Smith.
What's going on? We're here to talk about some algebra. Can we go into the big house?
Sure. It's the big house. Say hi to Mr. Smith, everybody. All right. So first, before we get into anything, we got to talk about some vocabulary. And we have 3 key words we have today. The first one of them is solution. You hear this word all the time. Solution. Solution, solution, solution. But sometimes you forget what they actually mean. So in solution in algebra, we're talking about the missing value that makes that equation work. So you see variables all the time. You see x's, you see y's, you see z's, you see t's, you see s's. We're trying to find the quantity that makes that equation work, and that's called our solution.
All right. The next vocabulary term is inequality. When you think about inequality, it means to be unequal, right? One side is maybe greater than or lesser than the other side. So when we're talking about inequality, we can talk about greater and lesser than. Remember, for inequalities, the mouth always eats the bigger number. And the smaller number is always the number that is being pointed at with here. So we have smaller number here. Okay, so the mouth is always eating the bigger number and the smaller number is being pointed to. Also, we want to know, what does it mean for absolute value? When you're absolutely certain, that means you're positive about it, right? You're positive you're right. Okay? Well, absolute value in math just means the number is always positive. So if we get something like, I don't know, maybe negative 6.543. If we take the absolute value of that number, it's just the positive number of it, 6.543. The absolute value measures the distance away the number is from 0 on a number line. And it's always, distance is always positive.
Okay, now we got our vocabulary down pat. We're good to go. The first step in everything is just knowing what you're talking about. So now we got a good old-fashioned, regular good old equation. You've seen this in Algebra 1. You've probably seen this in pre-algebra even. We're trying to find the solution to this equation. We're trying to find what value we can substitute for x to make this equation true. So it's very easy. Let's just undo our operations. So for the first thing, we want to get x by itself so we can find out what x equals. So I'm going to get rid of that 15. I'm going to add 15 to both sides. I'm going to come down low. I'm going to add 15 to both sides because I'm undoing the negative, undoing the subtraction. So I add 15. So I'm left with 5x equals, what's 20 plus 15? Well, it's 35. So now I'm here. And now there's one other operation to undo, and that is the 5 times x. The opposite of multiplication is division. So let me get rid of that 5 by dividing. And what I do to one side, I must do to the next. So 35 divided by 5 is 7. So our solution is x equals 7. If I plug 7 back into x up here, 5 times 7 minus 15, that's going to equal 20. That's magic. That's our solution. X equals 7.
All right. Mr. Athman, what we can also do, though, is we can solve for inequalities. Or whenever we see a less than or greater than sign here, we can use our same properties of finding a solution for inequalities. So here we have the same equation. The only thing difference is we have a greater than. 5x minus 15 is greater than 20. Another way to read it would be 20 is less than 5x minus 15. So we can use the same operations, undo the same operations just like we did with Mr. Athmer's equation. So I want to get x alone. I'm trying to solve for x. So I need to undo the subtracting 15. To do that, we add 15. Boom, 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 boom. The 15s cancel. I get 5x is greater than 20 plus 15. That's 35. So here, 5 times x, I need to undo my multiplication with the the opposite operation, which is division. 5 divided by 5. I get x is greater than 7. So now x could be 7, it could be 8, 9, maybe even it's 9.8654321. Any number that is greater than 7 fits for this inequality. Next up, though, we got to be careful when we work with inequalities here, when we have to work with negative numbers, when we're dividing or multiplying by negative numbers. So we have our same equation. The only thing difference is now it's negative 5 times x minus 15 is greater than 20. So follow our same steps, plus 15 on both sides to undo that 15. Boom. We get negative 5x is greater than 35. Okay. Here, the only thing different is now we have a negative 5 times x. So to undo our negative 5 times x, we need to divide by negative 5 on both sides. Okay? The thing is, though, when we divide or when we multiply by a negative, our inequalities have to flip. So now I write a new inequality. Negative 5 divided by negative 5 is 1, so I get x now is less than 35 divided by negative 5, that's a negative 7. X is now less than negative 7. So x could be negative 8, negative 9, negative 220 if it wanted. Any number less than negative 7.
Awesome. And we have one more type of equation that we need to deal with, and this has the good old-fashioned absolute value signs. This equation reads the absolute value of 5x minus 15 equals 20. And Mr. Kent talked about before that anything in these absolute value signs is positive. But what that gives us is two possible solutions. Because something in here could be negative or positive, they would both equal a positive 20. And that'll become more clear as we go. So the first thing we need to do is set up two equations. The first equation, let me get another color, Mr. Kent. Good teamwork. The first one we're going to set up and just take away the absolute value sign. So we're going to keep it 5x minus 15 equals 20. Alright, that's our first equation. Let's find the solution. Let's add 15 to both sides to undo the subtraction. So 5x equals 35, and let's undo this multiplication. Divide by 5, divide by 5, x equals 7. But we are not done yet. This is one possible solution. There's another one. So let's set up a second equation. And how to do this? We rewrite 5x minus 15 again. But this time, we make it equal to a negative 20. Negative 20 will provide us with another solution, and that will show that, hey, something in here, x could be one thing, and x could be another thing, and it could still give us the absolute value of that thing, which equals 20, a positive 20. So let's try it. Let's add 15 to both sides. Something else will come out of this. 5x equals, what's negative 20 plus 15? It's a negative 5. Let's undo the multiplication. Divide by 5. Divide by 5. X can also be negative 1. So with absolute value equations, we have to make sure that we get two solutions by setting up two equations. And Mr. Kent has some proof as to why we have two solutions.
Well, here's why we have two solutions. When you look at, we have two different numbers. I think everybody will agree that 20 is very different than negative 20. Okay? But when we throw those absolute value signs around them, the absolute value of 20, well, hey, that's just a positive 20. But the absolute value of negative 20 is also 20. So there are two different ways to get to our same 20 answer. Okay, so that's why we set up two equations for whenever we're solving for absolute value inequalities. So we'll throw it back to Mr. Athman.
Check this out. What he just said is totally right. Let's plug what we have back in here. The first solution was 7. If we plug 7 back into the equation, what do we get? 35 minus 15 equals 20. Checks out. And the second one, which might be tougher to visualize, let's check it out. If we plug in negative 1 for x in this equation, we get negative 5 minus 15 equals negative 20. Does that check out? Absolutely.
Mm-hmm.
So x can equal 20 and negative 20 when you have the absolute value signs, but what happens? It always becomes 20. So positives and negatives are dealt with the absolute values.
Go blue, get to work.